It's widely assumed that a modern air defense system can stop any drone attack. Russia believed exactly that about its positions on the approaches to Crimea. But 9 small drones shattered that confidence in less than 40 seconds and destroyed what Moscow considered untouchable. This isn't just about a burning train. This is about how Ukraine found and struck one of Russia's last intact logistics routes, the very one that command in Moscow believed was securely covered, and about what happened when Russia's electronic warfare system tried to stop it and failed. At 4:20 in the morning local time, 9 Ukrainian strike drones silently crossed the airspace over the Crimean peninsula. Their target was the Moscow-Simferopol Railway, one of Russia's last major logistics corridors, which up to that point had never once been hit by a Ukrainian strike. Running along that line was a train consisting of 21 cars. On board were more than 1,200 tons of artillery ammunition and 800 tons of fuel, destined to supply Russian forces in Crimea. For Russia, this was no ordinary freight run. After weeks of Ukrainian pressure, partial encirclement, and the peninsula's growing isolation, this train had become a true lifeline. Without that cargo, Russian units in Crimea would have faced a critical shortage of both fuel and shells. That's why the route was considered strategic, and that's why it was protected. Nobody in Russian command was prepared for what would happen in the next 90 seconds. The operation was built around the coordinated action of 11 drones operating under a single unified plan. At an altitude of roughly 2,700 meters above the target area, a reconnaissance drone, an Zhitel EVO-2 Dual 640T, was tracking the entire train in real time. A second identical unit was held in reserve nearby, in case the first lost signal suffered a technical failure or was suppressed by Russian electronic warfare. The strike package consisted of 9 highly maneuverable FPV drones. The reconnaissance platform wasn't chosen by accident. It isn't restricted by geofencing. It's harder to detect compared to standard commercial drones, and its dual camera system allows observation in both the visible spectrum and thermal. The thermal camera captured the heat signatures of the locomotive and fuel tankers, while the high-resolution optical camera provided detailed imagery for precise target identification. A satellite navigation system operating simultaneously across multiple global positioning networks allowed the drone to continuously update position and route data for the 9 approaching FPV drones. The strike drones themselves were compact, functional machines built for one purpose: to reach their target. Each was fitted with 10-inch propellers and 4 brushless electric motors. The warhead, armor-piercing, weighing around 3 kilograms, was designed for a penetrating strike. The battery pack gave the motors the ability to deliver short, powerful bursts of thrust. A flight controller running custom software continuously balanced thrust across all 4 motors, adjusted pitch angles, and kept each aircraft stable during low-altitude flight and sharp course changes. The design served a single goal: to survive air defense fire in the final seconds before impact and strike the target with precision. At a forward command post located roughly 37 kilometers from the strike zone, Ukrainian operators were studying every thermal frame coming in from the reconnaissance drone in real time. Against the cold terrain of the Crimean peninsula, a long, bright heat signature appeared on their screens. The Russian logistics train had been spotted, but Ukraine had known about it in advance. For 48 hours before the operation began, a covert reconnaissance network had been continuously tracking all Russian transport movements along that route. One key conclusion emerged from the data collected: this train always slowed, braked, and stopped for 1 minute at a military checkpoint in Taman, at the entrance to Crimea, as part of standard anti-sabotage procedures. That moment became the chosen attack window: speed at its minimum, fuel and ammunition cars nearly stationary, probability of a hit at its maximum. 4 seconds after target confirmation, the combat computer calculated the approach route for each FPV drone. Data on the train's position, speed, direction of travel, and optimal attack profile were synchronized and simultaneously transmitted to all 9 crews. That was the moment Russia tried to intervene. Roughly 5 kilometers from the railway track, a Russian electronic warfare system mounted on a wheeled chassis suddenly activated. This system is designed to suppress radio communications and satellite signals across a wide area. After detecting unusual signal sources near the train, it immediately shifted into intensive jamming mode across several frequency bands at once. The goal: force the drones to either crash or veer off course. Warning indicators for interference began flashing on the screens at the Ukrainian command post. The video feed from the FPV drones started freezing. Signal latency spiked sharply. Russian operators first deployed broadband jamming in an attempt to sever all communication between the drones and the ground control station. When that failed to produce the desired effect, they narrowed their focus and concentrated the full power of their suppression on two analog bands, 1.2 and 5.8 GHz, which are commonly used for video transmission and control of commercial UAVs. Had that worked, all 9 FPV drones would have lost their video signal on the final approach. But Ukraine had anticipated that scenario. Instead of fixed frequencies, the communication systems on both reconnaissance drones and all 9 strike drones were continuously frequency hopping, automatically switching to a new channel within an encrypted range every time the Russian system managed to lock onto the current frequency. The signal flickered on the operator's screens from time to time, but the connection never dropped once. Russia then deployed its last resort, GPS spoofing. Fake satellite signals were meant to convince the drones they were somewhere else and quietly steer them off course. But within 5 seconds, Ukraine's navigation system detected an anomaly. The GPS data had stopped matching the readings from the inertial measurement unit inside each aircraft. The onboard computer immediately flagged all incoming satellite signals as unreliable, removed them from the navigation process, and switched to a backup mode. Inertial data combined with imagery from the forward-facing camera. Trees along the railway track, power line poles, road signs, and roadside structures became the new navigational reference points. Each drone continued following the railroad, as if no jamming existed at all. Then the lead FPV's camera picked up the sign for the counter-terrorism inspection zone in Taman. This was the exact location Ukrainian intelligence had been tracking for several days. Below, the Russian locomotive began to brake. The target recognition algorithms on the FPV drones activated simultaneously. Trained on thousands of reconnaissance images of Russian railway equipment, they instantly identified the locomotive, fuel tankers, ammunition cars, and the distances between them. The onboard computer automatically calculated the strike point with the highest probability of serious damage, distributing targets among the drones so that multiple aircraft wouldn't hit the same spot. At 4:26:20, the attack order was given. The first 2 FPVs went straight for a car at the rear of the train. The armor-piercing warhead punched through the steel casing, and the packaging inside absorbed the blast. No chain detonation occurred. However, the deformed steel frame of the car caught on a wheel axle and began grinding against the rails. The engineer applied full throttle, but the train couldn't accelerate. At 4:27:20, 2 FPVs hit the 5th car, a fuel tanker, from 2 different angles. Both armor-piercing charges detonated almost simultaneously. The pressure at the point of impact ruptured the tanker's hull, and the fuel turned into a highly flammable aerosol. The temperature at the epicenter instantly exceeded 2,000 degrees. A fireball roughly 18 meters in diameter engulfed the 5th car, and a column of flame rose more than 30 meters into the air. The blast wave rolled along the length of the train. Fire broke out in the adjacent cars. The next 2 FPVs struck the artillery shell car. The first hit tore open the steel casing. The second, less than a second later, entered the exact same point. The heat and shrapnel initiated the shells inside. A chain of secondary explosions ripped the car apart. A column of fire roughly 45 meters high erupted from the middle of the train and merged with the blaze at the front. At 4:27:57, the last 2 FPVs hit the 18th car at the rear. A powerful explosion ruptured its hull and spread fire in both directions. By 4:28, three separate fires at the front, the middle, and the rear of the train had begun merging into a single strip of flame stretching hundreds of meters. The train, carrying more than 1,200 tons of artillery ammunition and 800 tons of fuel, was almost entirely engulfed. But this strike meant far more than the destruction of a single train. Temperatures above 1,000 degrees warped the rails, destroyed the ties, and damaged the ballast layer beneath the track. Unexploded ordnance and steel debris scattered across the entire zone made any immediate resumption of traffic impossible. Before the line could be put back into service, Russian engineers would have to extinguish the fire, clear the unexploded ordnance, remove the destroyed cars, and repair the track. That could take days or even weeks, with repair crews themselves exposed to the threat of another strike. A single blocked section of track creates a bottleneck effect. Military trains behind it are forced to wait. Shells, fuel, armored vehicles, and spare parts stop reaching Crimea on time. Russia can shift to road transport, but its capacity is nowhere near comparable to rail. To replace a single 21-car train, it would take dozens or even hundreds of trucks with drivers, fuel, and escorts. Those convoys would move along open routes where they are far easier to detect and strike with Ukrainian drones, artillery, and missiles. The consequences will ripple across the entire southern front. Crimea serves as a major rear base for Russian forces. When the supply flow is blocked, forward depots gradually burn through their reserves of fuel and ammunition. Artillery units are forced to reduce their rate of fire. Armored vehicles limit their movement. Reserves don't arrive when they're needed. Russia is also forced to redeploy additional air defense systems to cover the Kerch Bridge, the Taman station, and the remaining rail routes. Every surface-to-air missile system pulled from another sector to protect Crimea creates a new gap in Russia's defensive network. The alternative coastal rail route isn't truly safe either. It runs closer to the front line and remains within range of Ukrainian strike assets. That's the real significance of what happened here. Ukraine didn't just destroy a train. It is methodically turning Crimea from a military fortress into an isolated bridgehead where every train, every fuel tanker, and every supply convoy has to fight its way through an increasingly dangerous corridor. 9 drones punched through electronic jamming, destroyed fuel and ammunition cars, and disproved Russia's claim that the entrance to Crimea was securely defended. That train never made it to the peninsula. Its shells will never reach the front. Its fuel will never sustain Russian forces. In less than 40 seconds, Ukraine didn't just burn more than 2,000 tons of cargo. It brought Russia's entire logistics system on the approaches to Crimea to a halt. What do you think was the most significant aspect of this operation? The ability to defeat the electronic jamming, the precision of target selection, or the strike directly against Russia's logistics hub? Share your thoughts in the comments. If you're interested in in-depth analysis of drone tactics and logistics warfare in Crimea, hit like, subscribe to the channel, and turn on notifications so you don't miss the next episodes.